Hey, happy Friday. How's it going?
Happy Friday. Thanks for having me on. It's great to be here.
Yeah, anytime, anytime. Yeah, on today's show, we have Jordan Tigani. For people who don't know who you are, do you want to give a quick intro?
Yes, I'm currently starting up a company called MotherDuck. That's likely just a temporary placeholder name, but it's a name that started to grow on me. And kind of, I was also one of the founding engineers on Google BigQuery. I helped get that started, and built a lot of the pieces of it as an engineer. Ended up leading engineering, ended up leading product. Then I was chief product officer at Singlestore, so kind of got to see the startup side of things. And now I've been taking a lot of kind of what I've been learning in the last couple of jobs, and building a company around some ideas and opportunities in the data space.
That's cool. Yeah, I mean, we're big fans of BigQuery.
Yeah,
I suppose
yeah,
no
we're
pun.
fanboys here. I've read your book. It's a great book.
He'll autograph it for you later. Don't
That's
worry
right.
about it.
That's
I'll send you an autograph PDF. It's all good. So, yeah, so I think the topic for today's conversation, we want to talk about sort of what's next for analytical databases. I think anybody on this planet might have some, I think some very interesting viewpoints on this. I guess kind of maybe for the purpose of setting context and for history, like what's been the evolution of analytical databases up to today?
I think there was, the kind of the old school analytical databases, and like the data warehouse as this sort of giant box that kind of everything got consolidated into this kind of single massive piece of hardware, and that was partly just how things used to work, which was you needed a problem solved, and so you bought some hardware that helped you solve that problem, especially if it required significant processing power. I think then the kind of the in the early 2000s, when Google published the MapReduce paper and the Big Table paper, and a couple of GFS, et cetera, it sort of caused everybody to rethink about how they were doing analytics. And they're like, oh, I don't need this big giant box. I can actually scale this out to lots of little tiny commodity machines processing things in parallel. I can get things done much faster. And besides, big data, everybody's doing big data these days. And I think one of the interesting things that happened is that everybody, like when that came out, that really sort of broke people's brains. They started thinking differently about how they were solving problems. And I think sometimes the best meme, I mean, not in like the funny pictures, but in terms of just sort of like human ideas, some of the best ideas actually just cause people to think differently about things. And I think that was something that happened. You see the kind of the growth of these scale out systems. First you had Hadoop, and then the NoSQL, and then the things that were sort of building back SQL on top of those things, and you had the cloud data warehouses. And virtually since then, everybody has been building scale out systems. And I think one of the funny things is that the reason, the rationale for that is that data sizes were larger. Big data was the meme of the day. But it turns out that like most people aren't doing big data. And I actually like so I read the first few chapters of the book that you guys are working on. Really great read. But there was a tweet that you quoted. There's something about big data is like teen sex. Everybody thinks everybody else is doing it, so they say that they're doing it, but everybody's doing it poorly. And so I think there's sort of this opportunity here where like people don't actually need big data. And as one example, I saw there was a LinkedIn poll the other day, which was, and it was saying like, how big is your data warehouse? And kind of the lowest one was like under 10 terabytes, and then there were it went up from there, and almost everybody actually was under some 10 terabytes. So first of all, like the 10 terabytes was most people were doing less than that. But then the other thing is kind of how that they were describing how big the data warehouse was kind of rooted in old school technology. So like pretty much ever since the last 10 years, databases, data warehouses have been separating storage and compute. And so, your storage sits on object store somewhere, whether it's visible to you like in a lakehouse environment, or it's not visible to you like in a data warehouse environment. But the scaling of compute and storage is different. And so, very often you'll store the last 10 years worth of data. Like, why not store the last 10 years worth of data? Actually, one interesting definition I heard of big data was, when it's cheaper to just store everything than it is to figure out what to throw away. And I think, people have taken that to heart. And so now they have these giant data warehouses, which is the size of all of their data. But when you think about what actually do they use, it's much, much smaller than that. It tends to be, okay, you store the last 10 years of data, and but you actually only query the last 7 days or the last 1 day. And so, one of the things that, learning from BigQuery was, I used to do a lot of analytics over how BigQuery is being used. And so the drop off in terms of like query intensity over data age was massive. Like, so within the last, like something like 80% of, and I'm making most of these numbers up, so, please take them with a little bit of a grain of salt. Partly that helps me from like, revealing things that I shouldn't reveal because these are made up numbers. And, but 80% of all queries were over data from the last day. And then like 90% was like, or 95% was like the last 7 days. It kind of, after you get out, a couple of weeks, it's pretty minimal. And then you kind of see some of these, blips where, people are doing like 90-day queries, but those are pretty rare. So really so one way of measuring the size of your data warehouse is how much total data do you have? But I think that's kind of an archaic way of doing that, because like it's if you're never querying the data, should you really consider that part of your data warehouse, or should you really consider that as part of like your sizing decisions as you're sizing your data warehouse? Actually, the interesting part is the active data, and which tends to be much, much smaller. And so I think that, one of the ways that I'm betting, and I believe that things are going to go is sort of, from, we had this, single giant box, the Teradata, call it the Teradata era, then to kind of distributed, scattered out, very, very, everything is parallel, everything is, has got to be distributed. I think it turns out that like you don't necessarily need to just have distributed anymore, and because really the data sizes that you're using are not that huge, and also the sizes of individual machines have gotten a lot larger than they used to be, and so virtually any workload you can think of can fit on a single box. But anyway, I realize I kind of went a little long on that question, so I'll end it there.
It's really interesting. I guess the big data era as well, to kind of draw back to that real quick. It definitely seemed to be sort of a a competition amongst people. I remember where people, it's like, oh, how much data do you have? That was really the metric was quantity versus what are you doing with it, or what's the quality of it, and so forth. And it definitely, I think for a long time that even vendors would say, oh, well, you can house this much data. And it's like, well, but then you get into the real world and you start looking at clients and companies, and you realize like most people are kind of operating in maybe the gigs, maybe a few terabytes of data, but that's it. And that's, I would say, most companies, their data sizes just aren't that big.
Yeah, speaking of memes, I mean, there was just a lot of imitation going on of FANG companies where like Google and Facebook had these very specific problems, a lot of them graph problems around vast amounts of data that they needed to solve. And then every company out there was like, oh, we need that too. We'll be just as successful as Google. And then they ended up, using Hive and running some simple SQL queries on
like
the
a
latest
data or something.
Yeah, exactly.
Yeah, and they were unnecessarily slowing down their, what they were doing by like 3 orders of magnitude because they were using Hive. I recently talked to somebody who, he says he goes to these data conferences, and here's somebody from Netflix talking about the Netflix architecture and how they built things, and it's like, oh yeah, you get all excited about it, and you're like, but I can't actually use this. What am I going to do? Run a 1-node Kafka cluster and a 1-node Spark cluster, and it doesn't actually make sense. They're running a lot of infrastructure for kind of that's not actually needed. And when you simplify things, you can make them more reliable, you can make them faster, you can make them simpler, you can not just lower latency, but you can execute faster. And there's lots of kind of phase changes that happen when you can simplify what is actually going on. And just sort of one other thing on the data size is I think data at some point becomes a liability. Having in the area of was it CCPA and these privacy regulations, and you want to be able to not have PII data, and all the data that you keep around that's 4 years old, that oh, do I have PII in that, and how do I even I don't even remember the schema of that, or how do I cleanse that, and actually cleansing that's going to actually cost me a lot of money. It's discoverable in a legal sense. I'll give an apocryphal story about early days of BigQuery and Dremel, at one point Google didn't disclose what the power of Dremel was, because they were worried that Google gets sued a lot as any big company. They were worried that then that would make their discovery harder, because everybody's like, oh well, you can get this information really quickly and really easily, and it would actually have sort of negative impact on Google's legal perspective, if they let people know they had technology that can search things that fast. And this was something that I heard secondhand or thirdhand, so I don't want any of Google's lawyers to come out after me and say, hey, you
leave Jordan alone.
But I think and I think the interesting thing in this day and age is that, okay, now everybody assumes everybody has that kind of technology, everybody has that kind of power. So the liability isn't the technology, the liability is the data. Mm-hmm. And kind of if you have all this data, you might, and you're not actually using it. Another term that I learned from your guys' book was warn, write once, read never. And it's a lot of data just sort of gets written to your data lake, and then just sits there, and you don't actually need it. And then also just in terms of also as a liability. So let's say you want to go back and restate earnings, or compute what go back to the source data that may have been from years ago. The problem is your schema has probably changed. There's probably bugs at some point in those 10 years. There were certain bugs, and you were collecting the wrong data. So you have to make sure that you're filtering that out. You're handling it in the right way, or the interpretation of this field has changed over time. And so just having all that data and saying that we're going to it's not even that useful for going back and computing old things, because you can't get back into the mental state of, or you didn't document, or somebody didn't document what exactly that data was 10 years ago. And so it's only going to make you have make wrong decisions if you try to use that as the root cause. So I'm definitely somebody who has built their livelihood on big data. I think I used to do this petabyte query over BigQuery, and I'd get up at conferences and say, hey, look, I'm going to run a query over a petabyte of data, and everybody's like, ooh, a petabyte of data, that's a lot of data, and you can do this. Started out it was 5 minutes, and then we do it in 15 seconds, and then it was 3 seconds. And but I think also if you're really querying over a petabyte, it probably means your data architecture is bad. Because why would you do that? Because nothing you're going to do is going to really make, if you're going to make that fast, it means you're going to throw a ton of hardware at it. And if you want something to be interactive, or you're doing something in terms of if a dashboard has to query a petabyte of data, that's an interesting dashboard. I'm not sure how useful it's actually going to be.
Yeah, and again, a petabyte of data is very useful to Google. If you're scraping the entire web, then you're probably going to be, or Facebook, but like most companies, they should be optimizing somewhere else. Even if they have a petabyte of data, it should be down filtered and curated.
Right.
That's interesting. One of the things we were talking kind of before, you mentioned database innovation seems to be focused on types of questions you can ask rather than how your questions get answered. I think it sort of ties into that point. Do you want to elaborate on that? Because it's something that Matt and I kind of nerd out about, and we kind of want to get your take on that statement.
Yeah, sure. So I mean, there's a lot of database companies out there nowadays, and there's like, why are you creating another database company when there's several hundred database companies out there, and people already are inundated by the new ones. And I think a lot of the time, people are focusing on, okay, well, there's this type of question that I can't answer, or this type of question that this database doesn't necessarily answer well, and so I'm going to create a new database that handles that specific type of question, time series, graph, geospatial, or whatever. Like there's a bunch of these types of these new databases, and it's not to throw shade at them at all, but because they're hard problems to solve. But I also think that like the more you do these, the kind of the further out on the fringes of use cases you get. And I think part of it, the problem is you have database people building database companies, like understandable, because they're thinking about, okay, what other types of questions can I answer? And I think not necessarily, new database companies aren't being necessarily driven by practitioners or people that have encountered data problems. And so, the other thing is just the way a new database company tends to start is somebody builds an open source database. That open source gets adoption. The open source, then you get funding based on having adoption. You have a certain number of GitHub stars, et cetera. And then, but really your focus is on that open source database and the community. And then they're like, well, how are we going to make money? We'll make money by putting it in the cloud. We'll have the SaaS service. And the SaaS service is really seen as an afterthought, as something that is, we'll have a SaaS service. And the SaaS service tends to just be, we have a Kubernetes instance or a Kubernetes cluster. And when somebody wants to spin up this database, then a Kubernetes operation, the gears turn, and it boots machines and kind of does DNS entries, and then you have this clustered database running in the cloud, and it tends to be very hard to manage. It tends to be kind of slow, expensive. Doesn't scale. Doesn't necessarily scale particularly elastically. Kubernetes has some elasticity built in, but when you're trying to do this over a large cluster, it has a bunch of problems, has a bunch of limits, and just a lot of work involved in sort of making this run. And then just at the end of the day, like the people that are building these, for good reasons, are not focused on how do I make something amazing in the cloud and the things that you can only do in the cloud. And I think, to give an example of a company that I think is actually doing it well, PlanetScale is, I think one of the things they focus on is how do we, what are the things you can only do in the cloud, and what are the things that haven't been done before, and focusing on it from that perspective. And I think that, they are doing some really interesting things that have just an interesting philosophy of how databases should work. And I think that more people should be focusing on okay, now that you have it behind a SaaS interface, what are the things you can do? And I think people are they're kind of picking up the things that other people have, the things that are now table stakes: separation of storage and compute. Yes, you have to have separation of storage and compute. Serverless is also another buzzword, although what serverless means different things to different people. And sometimes, it's even people that are doing it well, it still means you take 15, 20 seconds, 30 seconds to start up. To me, that's not serverless. Serverless means you don't have an instance running, you send a query, or you send a database operation, and it responds in milliseconds. It responds basically as fast as it would have if you'd already had something spun up and running. And so I think that like true serverless is an area for innovation. I also think that where the database is running and how the database is running, and so just to give sort of another example would be in the big data era, and this is one of the mantras of BigQuery, and I think we cribbed this from Jim Gray, was you want to move the compute to the data rather than the data to the compute. And that was actually one of the kind of the underlying things about as we're building BigQuery. We're like, we have to have something you can do with these data sets, and SQL was nice because it was you can compute anything with SQL, but it actually always it's not Turing complete unless you have with recursive, which we didn't at the time, and so it always terminates. And anyway, so the move the compute to the data was very important for us. But if you're accepting the world where the data might not actually be all that big, or the active data might be all that big, then the important thing is latency. And many of these early systems, particularly distributed systems, were designed for kind of throughput rather than latency. But if you have a dashboard and you want to kind of understand what's going on in your business and you want to do drill downs, throughput is not as important. Being able as like getting an answer quickly. And in particular, if you have an application and the application is serving data for your users, like you want to get answers really quickly. So rather than actually moving compute to the data, which also means that the compute all is going to be centralized, and so basically, and you're going to be paying for the compute. What if you actually move the data to the customer and let the customer actually use their compute? And people their M1 Max now have incredible amount of power. If you leverage their compute so that you can give them a better experience. You can give them kind of really low latency. Like I saw a demo of something that a researcher had done. He's at CMU or MIT, I can't remember. Dominic Moritz. And like it was something that could do like drill downs on like a dashboard that had multiple connected graphs, and it could do kind of rescaling brush filters at 60 frames per second. Like 60 frames per second is crazy, but then it gives you just this amazing experience of like, hey, wow, I can do kind of whatever I want with this, and you just think about your dashboards, or think about dashboards that you've seen, and how far away they are from that, and what would have to happen in order to get to that level of experience. It's sort of very, very different. And I think if you're thinking about, okay, what types of queries can I run, what types of questions can I ask, then I think that's the wrong thing to be asking yourself. I mean, yes, some of those things are interesting, and some of those things do let you kind of solve problems and do things that you couldn't do before. But how do you get to a point where you can do that 60 frames per second dashboard drill down, and just make it make the sort of the penalty for clicking on something basically zero. I mean, that was I think that was the thing, like when Google came out, the reason that Google felt so magical wasn't necessarily just because the answers were better. It was because it was so fast that the penalty for having the wrong query and going back and changing the query was so low. And so, like, are there ways that how do you provide that kind of experience to database users? So I mean, those are some examples, and I one of the things I would love it if more database people would think about what are the things you can only do now. What are the things that are like, so things like I think PlanetScale doing some like forking of databases, and sort of like, and including schemas, and being able to sort of do get style databases, and then being able to sort of check have deploying things as sort of like the data as code types of approaches. I mean, there's all these things about how the databases and data is being managed that that can become interesting in a cloud world that would have been difficult in the old world. And if you're really just focusing on your sort of your database as something that can run anywhere, it's harder to focus on. It's harder to really innovate on some of these other ways of running your database, or being able to make lives easier for people that are using databases. Developer experience is another great one. It's like, how do you just sort of make it so that the database is as big as you need it to be, when you need it to be, and scaling up, scaling down, etc.
That's interesting. I mean, it fits in with one of the most common themes we see in our consulting, which is that customers come to us and they're using like a Snowflake or BigQuery or God forbid, like a Postgres or something, and they can't scale customer-facing analytics, so embedded analytics. So they have a SaaS platform, they're running something behind it for analytics, and once you start hitting that with thousands and thousands of customers in a centralized way, it becomes a huge problem. And the other thread I got from this is this idea of potentially pushing databases out. I mean, we've pushed so much out to web browsers using JavaScript, for example, and yet we're really not doing that in the same way with data at this point.
Yeah, I think being able to so I think WebAssembly is a super interesting technology, and I think we're going to start seeing more interesting things coming out of WebAssembly, and both client side and server side, and and I think WebAssembly lets you run things in browser that you didn't used to be able to run in your browser, and and can let you do things like run a full-fledged database in your in your browser. And so you can do things where you maybe have like this sort of tiered database, starts in your browser. It could be a CDN or a POP, and then could be kind of a local region, then could be sort of this sort of central regions, and each as I've been talking about this stuff, like database people love to geek out about this. It's like, it's like a query planning and query optimization problem. So they have a local database, and maybe it's in a data frame, and I want to join that against the database that lives in the cloud somewhere. It's an interesting query planning problem. Is like, well, do I move based on like the cost model and and table statistics and cardinality, like do I what do I move up, what do I pull down, do I just move a Bloom filter up and do parts of it here, and you can have queries that actually span from your client to the database, and with multiple stages in between. There's lots of kind of, I think, so far untapped things that you can do in that area.
Yeah, I remember the Singlestore people did a demo of some awesome stuff at my meetup a few months ago, and I was just blown away. I thought that was probably one of the best demos I've ever seen in my entire life. It was because it basically flipped the entire funnel on its head of how we think about databases right now. It's like, oh, it's just it's something you connect to, and that thing is over there. And yeah, the introduction of Lawson, I was like, holy crap, this is.
Yeah, I mean, one of the things that they, I was at Singlestore, and so I was kind of very I was involved in what some of the stuff that's going on there, and being able to push actually code into the database, and sort of you can move data, and then you can also move code and figure out okay, where's the best place for this code to run? Should this code run? You can write code locally client side, you can write a loop client side, and that calls a function, and that function can actually get pushed into the database, so that when we were operating over the data, it's actually calling into the same function. There's just some really kind of neat things that you can do with web. I think WebAssembly is one of the kind of enabling technologies, because really any code that you can run, you can run it locally, and you can push that into the database.
Well, you're absolutely right too about the latent computing power just sitting around us. I mean, I wager to guess that all of our computers are basically kind of mostly idle. I don't think anyone's tapped out. We kind of nerd out on this once in a while too, where it's kind of I think we had some I don't know, some fun talking about, okay, so thought experiment, what if you had a decentralized cloud that just operated on basically your phone and your laptop, right? It could probably work actually if you were to kind of barricade everything off, just because there's so much. If you just look around you, I mean, in my house, I don't know how many computers I have that are just sitting around not doing anything. There's a ton of power, and it's probably more than you need to run analytics, for example.
Yeah, it's like they say that the cloud is basically just somebody else's computer, but why not use your computer, and your computer, like, other example is like there's for secure computing and privacy, like if you basically can say, okay, well, the keys or the PII data never leaves my house, never leaves my computer, but I can still do queries. I can still join against this other giant data set. Are there ways that you can do kind of secure computing by moving some things locally and moving some things into the client? Like in in BigQuery, we had there was a research team at Google that was working on some homomorphic encryption, and there are some of the homomorphic encryption functions built into Dremel, built into BigQuery, so that you do things like you could do aggregations over encrypted data. But one of the problems with that is in order to do that well, you need to have a full parser and expression evaluator locally in the client. And at the time, like, that didn't exist. So it was like this sort of like hacky thing, and you had to go through like this one specific client. But I think when you can really run a full version of the database locally, then kind of the opportunities for actually doing real, secure computing and operating over encrypted data, and being able to do that in a more seamless way and a more performant way is huge, because actually some of those things are actually are incredibly computationally expensive to sort of do well, and then the results sometimes are like, yeah, this is a little bit surprising, and just because you have to. Anyway, I won't go into that.
Or do so.
Well, I mean, just you have to separate out, if you're going to do an aggregation, you have to, when you encrypt the data, you have to figure out, okay, well, do I want repeatable encryption or not? And so, like, if you want, let's say, it's cars, and or car manufacturers, and there's only 30 car manufacturers, and so if you encrypt them repeatably, then you could actually do kind of a frequency analysis by thinking, well, Ford is the biggest, sells the most cars. I don't know if that's true, but Ford sells the most cars, and so if I did a count of how many, if I did a count, I only see the encrypted value, but whatever the one that has the most cars, that's going to be Ford. And so you can actually sort of figure out by other context clues what those values are. So the other way you can encrypt it is you can encrypt it so, okay, every time Ford is encrypted, it'll be different. Of course, that causes the data sizes to explode, because you can't use dictionary encoding under the covers, and it also means you can't do real aggregations. You can't do count, with sort of most techniques. So it's hard to make it really transparent. But anyway, I think it's an interesting, interesting problems, and I think that we're going to start to see some more of these types of problems be tractable when you can do more things on the client side. Because one of the other things in BigQuery is people always said, well, I don't want to. I want to do kind of customer supplied encryption keys. I don't want Google to ever have access to or be able to decrypt my data. And it's like, well, wait, but in order for us to run the query, we have to be able to decrypt. We have to be able to operate over the data. If you and you have to give us the key at some point. And yes, we can promise to throw away the key. There's a whole bunch of things you can do, and things that interesting ways that we were able to sort of solve some of those problems. But I think it would be really nice if I could query over, what are the logs that Google knows about me? What's the information Google knows about me? And I can query over that without Google actually being able to sort of read that data, or I could, that I never have to supply my encryption key.
So here's an interesting question. What about code protection for a vendor. So presumably, if you're developing this code, this product, you still have to ship it across to someone's web browser. Does using WebAssembly make this kind of technology more resistant to disassembly and reverse engineering, if that's something that you're interested in as a vendor who's like supplying kind of this hybrid database that pushes out to the edge?
That's an interesting idea. I think at the end of the day, if you're running something on somebody's machine, somebody determined is going to be able to reverse engineer that. But I think if what you're shipping is a binary that runs under WASM, it may be a little bit more resistant than if it's just JavaScript. But I don't know. I don't know. Maybe there are ways of doing that, but I don't know. I think at the end of the day, like you're running something locally. You can run it under a debugger. You can run it like a determined reverse engineer can figure out what's going on.
Interesting. Kind of back to something you talked about earlier, scaling up and scaling down. You seem to be a fan of scaling down, actually. You want to unpack that?
Yeah. So this is something that I'd seen a couple of times. So one of the interesting things is like, as I was sort of talking through the ideas behind MotherDuck, I was talking to Brian Bershad, who is he was the site director of the Google Seattle office for a long time, and he was an entrepreneur, et cetera. And he is really the person who should get credit, or he was responsible for creating Google's cloud. So Google Compute Engine, Google Cloud Storage, BigQuery, what became Dataflow, much of what's, the key products in Google's cloud were basically started in the Seattle office. And there was like, part of one floor in a small building in the Seattle office that had all these teams. So anyway, I was talking to him about this and talking about BigQuery, and I was saying that that there's like tens of thousands of small customers in BigQuery that only have a few gigabytes of data, and he said, well, why would they use BigQuery? Like why would they use BigQuery? Like the whole point of BigQuery is because you have big data, right? And and then we thought about it as like, no, actually, really, it's two products. There's BigQuery, and that you're dealing with giant amounts of data, and you need to crunch this giant amount of data. And yeah, BigQuery is wonderful for that. But it's also easy query. It's like one of the things where you walk up, there's a SQL command prompt, you type in your query, you load your data, and it just runs, and you know exactly how much it's going to cost. Somebody I was just talking to said like, yeah, we all these people that we talk to, like they have like, they're using BigQuery and they have sort of laughably small bills. They're like $5 a month. They're like
pretty insane, actually.
Even big customers, like we migrated one customer from like an on-prem Oracle system, and I think for at least 1 or 2 years they ended up spending less than $100 a month. This is a big company.
Yeah, it was an expensive Oracle database, as you can imagine. These things aren't cheap. Yeah, I guess I think small query doesn't have the same ring to it though.
No,
so
easy query kind of does, but
easy query I think is good. But I think it's really valuable to have just something that's easy and something that is just is inexpensive, and like so the kind of the barrier to entry is very small. So like not to crap on Snowflake, but like their smallest size is like $1,500 a month. So if you're running it 24/7, it's like $1,500 a month, and for a lot of people, like that's a daunting thing to say. Okay, I need to run this dashboard. I need to power this dashboard. Like, are you really going to spin up something that costs a couple thousand dollars, tens of $1,000s a year, versus like. In BigQuery, you could do that for a couple dollars, and so what I think there's a lot of value to like the entry level, and I don't mean like a debug version, but the entry level of something that's actually useful should be a few dollars a month. Should be something that like somebody is who's thinking about starting a dashboard or who's thinking about building a dashboard is like, all right, I'm just going to put this on my credit card because like whatever, I just need to get this done, and then I'll file for, I'll expense it or something. And it's like even if you're, you know, your standard is you're using Snowflake or using something else, like, you know, people who want to get something done and and are going to try something new, it's got to be super inexpensive. And so some people are doing, like, you know, there's, you know, generous free tiers and always free tiers. But the problem with that is if you go from zero to thousands of dollars a year, that's you know, very daunting for people. But if you go from zero to, okay, I'm going to use a little bit more and it's a couple dollars a month, I'm going to use a little bit more and it's a couple more dollars a month, and maybe it's $100 a month, and then it's just, you want to have, I think it's really important to have this sort of smooth curve with no discontinuities for, like, you know, going from zero to larger data sizes, because you just, then the mental barrier, the mental friction to sort of having people start using it is so much lower.
Yeah,
and I think
sure. I mean, and that's oh, sorry, what are you saying?
Oh, I was just thinking it gets back to like what I was talking about earlier, which was, you know, the kind of innovation, how people are doing things, and like this sort of the model where every time you start up a database, it's this sort of Kubernetes cluster. You know, it's a you know, especially these scale out things. You know, it's multiple machines and you have high availability, so there's multiple of those running. Like, it's very, very, very hard to do those inexpensively. And so that's often why the minimum sizes that people have are in the hundreds of dollars a month, you know, thousands of dollars a year. And it's just because you can't make it work from an economics perspective if every time you know, start a database, it's something that, you know, is managed by Kubernetes and it spins up virtual machines. And so I think that, you know, scaling down is actually it's important, and it's also something that, like, that means it's an architectural decision about how you're going to have to build that. Because if you're relying on, you know, kind of Kubernetes to spin up virtual machines, like, yeah, it's going to be expensive.
Well, yeah, for the vendor especially, right? And so they have to pass it on somehow.
Yes.
And that's one thing when we work with Snowflake for full transparency. And I think that the big thing we always emphasize to our clients is you can definitely run it cheap. You have to be very careful in how you do things. So, like, we always suggest to start with an extra small, for example, right? And make sure you auto suspend after certain times, so you're not getting banked. And it's just, there's a lot of steps, and we can definitely make it work. But we had one client, I think they purchased an enormous amount of credits. They blew through 10% of them in like a few days, which was because they're like, oh, I'll just spin up the largest warehouse, and, you know, they're doing all these kind of merges and stuff, which we're just chewing through compute. So part of it too is like it's you know, FinOps is like something that Matt and I have been talking a lot about, and just cost management with these databases, because you know, there's a lot of great databases out there, but if you don't know how to query them effectively, store your data effectively, and also how the pricing works and how the best practices behind that, it's not a fun day for you, especially when you have to go talk to your CFO about why you just spent a bunch of money that you shouldn't have.
And the other thing I'll add to the FinOps combo is there are kind of two parts of FinOps, and one of these gets forgotten quite a bit because people are very worried about their bills. The one part is controlling costs. The other part is generating value. And I think BigQuery and even Snowflake, I mean, it's dirt cheap compared to what you used to be able to, you know, buying a Teradata contract or something like that, have democratized data. And so now even small spenders can start generating value. You know, these like small accounting shops that used to do things in Excel can now do things in BigQuery or Snowflake and get way, way more value out of it. So maybe that's part of like the scaling down conversation. Then instead of just reaching large businesses, we can now reach across small businesses, even solo practices and things where data is just one corner of their business.
Well, okay, so let me talk about this though too, because I think the most ubiquitous data platform that's, let me see, is on a computer, seems to work really well and used by the most people is Excel.
Sure.
Right. So. And that's, and I was talking to somebody about this yesterday because they're asking, I learned data discovery. And I'm like, you know, I think your tool is focused in the right areas, like in the database, but you're ignoring the dark matter of like almost every business now, which is the fact that most people do stuff on spreadsheets, and they have no notion that you even have a data warehouse typically, because they're just like, oh, I just do my Excel sheet, and that's it. So, I mean, I don't know if that's food for thought or just more of a tangent, but it's one of these things where I don't know if this couples the idea of pushing compute there, but I can definitely see some harmonies in that sense, where I think people are just so used to doing analysis on their computers anyway, because they're doing it in spreadsheets, right? And even the notion of doing it in the cloud, like Office 365 online or something, is still like a foreign concept to a lot of people that I see. So like I go to companies, I just, I see that they have very sophisticated data systems, and I, look at how the executives are making decisions. And they're like, yeah, I just have my spreadsheet. I don't know who put this together. Like, there's a huge
Yeah,
disconnect.
somebody from Excel said like, yeah, Excel is like always the second best tool for every job. And there's just a lot of times where Excel is, Excel gets used, all over the place, or spreadsheets get used all over the place. And I think that's why, you're seeing companies, BigQuery is, has really good integration with Google Sheets. And
Right.
I think there's a lot of interesting stuff there. But Matt, I did want to mention, you were talking about, one of the reasons that people are using more and more Snowflake, and it gets more and more expensive is because they're finding value. And I guess, and because there is a good kind of a direct correlation of value to cost, so that as people realize that, hey, this is working well, they do more and more of it, they're getting more value out of it. And that's why, they're okay with, or comfortable with, reasonably, the amount of money they're spending, is because, like, hey, we're doing all this more analytics, and it's more, it's costing us more, but also we're actually getting, it's solving real business problems for it, and it's helping us. But it's also one reason why I think auto suspend, that was mentioned earlier, is a little bit of like it's a kind of a false drug, or it's because it's really easy to sort of say, oh, well, don't worry, this is, auto suspend, and I'll only spend a couple dollars because I'm only running it for a couple hours a day. But then you start doing it for a couple more workloads, and or you have an ingestion pipeline that runs all the time, or you have somebody runs a cron job and it, is running over and over again, or somebody complains that it takes too long to sort of rehydrate and respin it up. And so all of a sudden it's on 24/7. And then, instead of spending it only on being on, during work hours, it's on 24/7. And that's 5x, 5x more cost than you had originally budgeted. One of the things that I did actually in BigQuery is, because I was trying to compute how important is auto suspend actually. And so I looked at, BigQuery reservations, I basically said I mapped those to, okay, these are effectively a data warehouse. And so I'm like, for each one of these reservations, BigQuery reserved instances, and often you can have you can split those up by project. So each one of those, I called them as the equivalent of a Snowflake data warehouse. And it's like, okay, if this was a separate data warehouse, how often would it be on? And I found that I looked at, during a POC, during the time when people were kicking the tires, they were on 10%, 20% of the time. Then after people had been running for more than 6 months, they were on 98, 99% of the time. So it's sort of during the POC, you're kicking the tires. Oh yeah, it's going to shut off all the time. This is going to be great. And then you kind of start using it for a while, and you end up using it all the time. And of course, in a case where in BigQuery, there wasn't a financial impact to that, and so there was no incentive to make it only run a portion of the time. But it also is something that it can sneakily get in and kind of cause your costs to increase pretty significantly.
This happens.
It becomes kind of like a drug addiction after a while. You just can't quit, right?
Well, you got to get your data somewhere.
You got to get your data.
On, man.
I guess I don't know. MotherDuck could be the methadone of if Snowflake is heroin. I don't think we want to go there. I don't think that's the right.
What about MotherDuck? What's up with the name? We had a few questions about that. George Farrakhan had asked that earlier in the chat here. It's a cool name. It's also a bit different.
It's cryptic. Let's say that.
It is cryptic. DuckDB is in case folks aren't familiar with that, it's a it's an analytics, a lightweight in-process analytics database that is, I think similar to the, SQLite for analytics. It was created by a couple of, researchers in the Netherlands who kind of really wanted a clean research platform for being able to sort of do research on databases, particularly in the fields of analytics. And they realized there wasn't a good one. They started out using MonadDB, which was, I think, also created by some of the folks in the same organization. And they're like, no, we want something that's just cleaner and more modern code base. And so they built something that is actually really pretty extraordinary. Like the performance is really good. The simplicity is good. I was talking about WASM before. It can run in the browser. It can run in WASM. It has 0 dependencies, has a really good Parquet reader, great and great extensibility, lots of extensibility points. So, probably from the name, you can guess that we're doing stuff with DuckDB. We're working really closely with the DuckDB team. Like I just spent most of this week in Amsterdam, kind of working with those folks, and because I think that you could. If you're going to build a database, an analytics database, you want to start with the kind of the most robust thing that's easiest to build on top of. And I think DuckDB works incredibly well for that. And the other thing is, as we're talking about, scaling down, it's so lightweight. You can, it's a couple of megabytes. It can scale down nicely. And I was also talking, scaling up. You can, and so it's single node. So that's one of the things that, most analytics databases are multiple, are distributed. And, but like scaling up is actually quite powerful. And people have sort of forgotten, what you can do on a single node. And sort of as a proof of concept, that is sort of some back of the envelope math, comparing like, BigQuery to what you can do on a single node. So by default, in BigQuery, you get 2,000 slots, and 99.99% of big people in BigQuery use less than 2,000 slots. Even people that are buying BigQuery reservations are still using 2,000 slots or less per workload. They'll divide. They might have 20,000 slots, but they'll kind of divide things up into projects that are doing sub reservations that are doing 2,000 slots or less. And it's about $500,000 worth of BigQuery a year. So it's a pretty significant chunk. Like you can do the hardware that BigQuery uses for 2,000 slots. You can put it on a single machine. So anything you basically almost anything you're doing in BigQuery, even BigQuery, can be in a single machine. Like in AWS, you can spin up a single machine that has 24 terabytes of RAM and 448 cores. The thing that actually is going to get you, the thing that is going to be tricky is network. But I have so you can get 100 gigabits into a single machine. And I think a couple of them are 200 gigabits, but my understanding is that they're soon will be releasing on AWS 800 gigabits. So basically 100 gigabytes, and if you consider that as compressed, how much data you actually have to read off of disk, you can really do terabyte per second scans. And I think one of the things that the original Dremel paper claimed is we can do a terabyte scan in a second, and that was kind of blew people's minds. And partly they were doing some tricks. One trick was column projection, because it was early column store, and they were also doing compression, and so I think so you can do basically you can do that on a single machine these days. And so kind of looking at sort of what can you get from scale up, what can you get from scale down. And and some of these things that I've been talking about, like that, I think we should be able to do is, being able to push compute out to users, being able to do, true serverless, easy, the easy query types of things. These are things that we're kind of putting into MotherDuck. I don't want to I'm not trying to be coy about what we're going to do. It's not that not that I'm like, no, we're in stealth mode, I'm not going to tell you. I'm happy to talk about it, but I also just don't want it to seem like, vaporware, because we are still sort of like early-ish stages. And like, once we have something that we can, prove, does all the things that we say it's going to do, then we'll sort of, we'll talk about it until your ears fall off. But before then, I just sort of want to talk about like the problems that we're solving. And it might be that other people recognize those same problems and are like, hey, we're gonna come and compete with you. And like, hey, that's fine. I think one of the things that was great in BigQuery is when Snowflake came on the scene, it really pushed us to do a lot better and work harder and kind of recognize what the real problems. And I think the overall analytics space is stronger for that type of competition.
It's interesting. As I hear you talking about scaling down, it's funny because the way I perceive that, paradoxically, you're also kind of talking about scaling up. And what I mean is this: you're talking about moving away from like centralizing clusters on, or centralizing queries on a cluster that runs on AWS or GCP or something like this. And instead, now we're going to scale up by pushing out to, say, 1 million different users. And it's kind of very similar to what Netflix has done to scale up their video distribution. It's not that they have like these huge data centers pushing video out to 10 million, 100 million viewers. They actually push the storage out to individual ISPs. And this is like, and then you're pushing the actual video playback processing out to individual devices, to phones, to iPads, to devices connected to people's TVs. And so you're talking like a vast scale of data movement.
I mean, it kind of reminds me of a CDN for
very much
OLAP,
so.
actually.
Except now for the queries themselves, and yet still you can presumably you can push down some of that work to a centralized database where you need to slice and dice and cut down what you're pushing across the network. But then once you push across, you can get this ultra high performance across millions of users potentially.
Yep, and low latency and you don't have to, because I think in a data application, you want you have to be able to handle high concurrency. And I think, as was mentioned before, like that many data warehouses don't really handle that super well. If you end up having end users that do things that look like analytics queries, and you try to serve those with your data warehouse, like that's just a recipe for tears. Because if you try to like, I think Snowflake likes to say they can handle infinite concurrency, and the way they do that is they spin up new Snowflake instances. And yes, they can handle it, and it's going to be incredibly expensive. And to some extent, like if you got to run a query and you got to run it in the cloud, there's no silver bullet to being able to handle high concurrency if you have to centralize all that compute. Yes, you can do things that are more efficient. You can do things that are, the faster your queries are, the more of those you can do per second. And so the lower your actual concurrency has to be. Because if you could do, 1,000 queries per second, and you have 10,000 users, well, it's an average of 10 queries per average concurrency of 10. Whereas if your queries take a second to run, then your concurrency is going to have to be a lot harder to handle that same load. But assuming that there's no silver bullets for like making things 1,000 times faster. The kind of the way that you can handle that higher concurrency is you make it so you don't have to do all of that yourself. You make you run on somebody's laptop, you run a CDN, you run in another region, you run kind of something that doesn't have to all be tied to the same compute cluster.
Very interesting. This is fascinating. It's also interesting too, because I think you're one of the people that, in our opinions, I think it sort of spearheaded the big data, right? And now it's like the pendulum swung, and now it's small data. So, but
I was I think I built my career talking about big data and like, hey, look how we can query this petabyte, and then I think just one of the things you learn is like that you more and more people are like, yeah, but actually our data set is only this large. And that, at Singlestore, we certainly found that a lot, is that people were using smaller data set sizes. And it's like, yeah, you could run this on a single machine, and also just the amount of complexity in a database that goes into the distributed execution and the distributed model. Okay, what happens if this fails? What happens if that fails? How do you do kind of commits across, these multiple nodes, and synchronization and clock skew and shuffle. Shuffle is really a pain in the butt because you have to move data from one place to the other, and huge teams and at Google we're working on this, and specialized, leveraging specialized hardware, on a single node. You just put it all in a hash table and you share a pointer to the hash table. Like that's it. Like that's so easy. And so that means you can spend your time on other stuff. You can spend your time on innovating on other things rather than kind of dealing with the distributed compute mechanisms. And yes, as you try to scale up, you may have to add some of those pieces back in, like dealing with NUMA, et cetera. But on the other hand, you may not, and you still, you should be able to make it a lot simpler.
Interesting. We know we're coming up on time. We'll have to have you back on when MotherDuck is a bit more official. So you're welcome back anytime, of course. But
yeah, lifetime privileges after helping us to review the book and everything.
Excellent. Yeah, I mean, I'd like to talk about it when it's not vaporware, when it's actually real, and we can talk about some of the cool things it could do. But that's also one of the fun things is like when it is vaporware, I can just talk about things that I think are interesting and things that are fun. Probably better than trying to shill something that I'm trying to sell.
No, you can shill ideas and dreams and hopes, and so I bet this is like kind of the fun part of the startup phase, though, is the ideation. There's not a lot of expectations yet. It's just what's going on in the head of Jordan these days. So it's awesome.
Fun and terrifying at the same time. So.
That's cool. And again, love the name. I think it was pretty hilarious when I saw your you switched titles or something. I was like, MotherDuck, that's awesome. That's actually
awesome.
It's like, go Jordan. So,
well, and I mean, think about your super successul tech companies. Weird names: Amazon, Google. So
it's
probably
for
Console
success. Actually,
for success.
It has to work. Yeah. So
people that complain. A lot of people are like, MotherDuck. That's kind of a weird name. I'm like, look, Cockroach is doing really well, and
True.
That's a
Mongo.
Many people do not like that name. My wife has a good test. Is like, and she's like, Cockroach. Is like, really, Cockroach? Like that? Like, why would you want to name your company after like a gross insect? But
it all comes down to
nuclear. They have great tech.
Yeah, no. Snowflake was the same way. I think that when that name came out, people were like, what are you talking about? So I think people.
You're a database guy, like Snowflake schema. Like I thought it was brilliant.
I thought it was good too. Yeah, Snowflake schema. That's the first thing I thought. I was like, really, you want to do that, huh? But no, it's awesome. It's a great name. And again, it's just definitely one of the most compelling ideas I've heard in a long time. I think
it's very, very cool.
Sure, Matt and I'll be sitting up on my patio afterward, just nerding out on this idea. So,
yeah, exactly. We could talk about this. I feel like we could continue this conversation all day. So
yeah. Well, at another point. So
yeah, cool. Another time.
Yeah, cool. Jordan, thanks for being on the show. Thanks to the audience for a lot of the comments and questions. Sorry we didn't get to anybody's question, actually, but that's how it goes sometimes. Monday, we actually have Igor from Big Eye. He's going to be on talking about observability and all that fun stuff. So stay tuned for that. And I think that's about it. So cool.
Thanks so much.
Yeah, happy Friday, everybody. See ya. Bye.